Hi everyone, welcome back to Preformulation Study, Formulation and Pharmaceutical Science Perspective, Part 4. This online lecture on pharmaceutical sciences is sponsored by Gold Pharmacy under the philanthropic vision of quality pharmacy education for all. So we are discussing about all the way different factors, how to develop the pre-stable formulation. Under this analysis, after doing quite analytical studies, now we are going to focus on certain analytical parameters and how it's going to influence the product development or a pre-formulation study. Now, one of the important parameter is solubility analysis. And input solubility is an important physical and chemical properties of a drug substance which will be influence the solubility of a drug. Basically, solubility is measured in a aqueous system or aqueous solubility will be determined with water or any aqueous system. So, drug must possess some aqueous solubility for a therapeutic efficacy in the physiological pH range from 1 to 8. For the drug to enter into systemic circulation to exert a therapeutic effect, it must be first in solution form. So basically, when a drug going to is solubilized and it should have some minimum solubility to get a better circulation, better bioavailability, it need a minimum solubility or aqueous solubility property. If solubility of the drug substance is less than the desirable, then it is going to consider to be increase the solubility of the drug substance to achieve the minimum requirement to get the drug to absorb to systemic circulation. So most of the time it is noticed that poor solubility less than 10 milligram per ml may exist a incomplete or erratic absorption over a pH range of 1 to 7 at 30 degrees 37 degrees centigrade body temperature. However, two important fundamental properties such as intrinsic solubility and dissolution rate constant or and dissociation constant is going to be important parameter to understand the solubility of a drug substance. So intrinsic solubility and dissociation rate constant or dissociation constant pKa is going to be determine the drug solubility nature. Solubility analysis, when we carried out, set in many parameters or many factors going to influence the solubility of a drug substance or any new chemical entities, such as like lattice energy, molecular arrangement, bond strength, weak bonding forces, lipophilicity, ionization, pH, co-solvency, additive, dielectric constant, solubilization by surfactant, hydrotrophy, complexation, temperature, pressure, and molecular volume. These are the factors going to influence the solubility of a drug substance or a new chemical entity. How to determine the solubility? So determine solubility can be determined by using a equilibrium of the drug substance or solubility of a drug in a certain solvent. So the drug is dispersed in a solvent, the suspension is agitated at a constant temperature, and the sample of suspensions are withdrawn as a function of time, clarified then means filtered by centrifugation method, then assay and analyze the drug content and to find out where the drug gets saturated or reach the plateau concentration. So you can notice here that with due course of the time, the drug concentration keep on increasing, but at equilibrium, then it will be reached to a maximum reach to the equilibrium state that's called the plateau state, where the maximum solubility will be achieved. Mostly the solvents, as I said, the solubility is determined with water, aqueous solubility. Sometimes even we also use to take different solvent with the different conditions like 0.9% sodium chloride normal saline at room temperature or 0.01 molar hydrochloric acid at room temperature or zero point 0.1 hydrochloric acid or zero point 0.1 sodium hydroxide at relative humidity and temperature conditions, and pH of 7 to 7.4 pH and buffer condition also carried out to understand the solubility of the drug behavior. So the drug concentration is once reached to the plateau or equilibrium state is going to be determined by analytical methods. Many analytical technical methods can be adopted such as high performance liquid chromatography or spectroscopic method, fluorescence spectroscopy or gas chromatography techniques can be adopted for analysis of solubility of a drug substance. Here in one we have noticed or paper presented over here that how the drug substance in different condition, like here the example is saturation solubility study of glycoside is loaded PLGA formulation with in different conditions, different medium conditions like phosphate buffer, pH 6.8, 0.1 N hydrochloric acid, pH 1.2 and distilled water has carried out. So it is depend on the nature of the drug substance, the solubility is going to be achieve higher solubility in different solvent system. So as I said, dissociation constant is going to play a very important role in solubility and also in bioavailability, and the drug molecules going to be determined based on its solubility and dissociation constant. So the pKa is the dissociation constant will be determined for weakly acidic drug or basic drug partially ionized in the GI fluid. Generally, it is noticed that unionized molecules will be have better absorption profile and better bioavailability. So to understand how much degree of the drug get unionized to ionized, normally we adopt the Henderson-Hasselbalch equation to understand the percentage of ionized to percentage of unionized at a particular pH. For a acidic drug, the pH can be calculated for acidic drug, the pH at particular pH, the pK plus log ionized by unionized, and from this equation we can able to understand what is the percentage of unionized molecule at that particular pH going to be determined. Similarly, in a basic compound, the pH equal to pK plus log unionized by ionized. Again here we are going to determine what is the percentage of that molecule will be remain unionized is a predeterminant and going to determine the overall pathway of drug bioavailability, means how much unionized drug molecule will be associated, so that will be determine the better permeation, better absorption and better bioavailability. So, as I said, the PK is going to be a critical role in understanding the drug delivery or development for the better bioavailability, better absorption profile. So, here a thumb rule is that weakly acidic drug around 4 pKa value are better absorbed, faster absorbed in the stomach, whereas the drug molecule which is unionized in that particular stomach pK at this point and will having better absorption profile. Similarly, the basic drug with 8 pKa value shows a large percentage of unionized form in the intestine and better absorption profile. Excuse me. Determination of the pK, the potentiometric titration can be carried out to understand, or spectrophotometric determination or dissolution rate method can be adopted, or liquid-liquid partition coefficient method can be adopted in determination of dissociation constant. Next parameter is the partition coefficient, and the partition coefficient is the lipophilicity of a organic compound is usually determined in terms of the partition coefficient or log p value, which can be defined as the ratio of concentration of the unionized compound at equilibrium between the organic to aqueous phase. This partition coefficient helps in prediction of the drug ability how to cross the biological membrane or bilayer membrane. So Lipinski rules of 5 can be used to predict the solubility and permeability of a newly developed chemical entity or a drug molecule. Log P can be determined with the formula of log P equal to oil by water ratio at equilibrium state. 0 represent log P value indicate that the drug substance is similar solubility in both organic like an octanol and water, means equally distributed into both the phase. Similarly, log 2 represent the compound is highly towards the hydrophilic nature and drug log p value 5 indicate more lipophilic nature of the drug compound or new chemical entity. So a suitable absorption profile for a particular drug compound or a new chemical entity must be the log p value within 1 to 3. So log p value less than 1, more than 6 represent a poor permeability and it is going to be a critical for a delivery of a or crossing the biological barrier of the system. So nowadays this log P can be determined by using a software system like a molecular modeling pro can be used to understand the drugs, what is the partition coefficient or lipophilicity. Different techniques can be adapted to understand the partition coefficient like we it's very commonly we used to do the sec flask method, chromatographic method, counter current and filter probe method, Tomlinson's filters probe method or microelectrometric titration methods. These are the techniques by which we can determine the lipophilicity or partition coefficient. As I said, the application of partition coefficient is to understand the lipophilicity characteristic of the molecule. Similarly, we can understand what is the how much antibiotics or fermentation will be recovered or extraction of the drug from a biological fluid for therapeutic monitoring, absorption of a drug from the dosage form like ointments, suppositories, transdermal patches to understand how much its penetration through the biological barrier going to be. It is going to determine and helpful in understanding or developing of a dosage form. Study of distribution of the flavoring oils between the oils and water emulsion also can be understood, can be determined or clearly better understood by this parameter called partition coefficient. So solubilization is the technique by which we can improve the solubility of a drug substance. If it is showing a poor water solubility, then normally pre-formulation study we adopt certain technology or methodology to improve the solubility of a drug substance. Because as I said, solubility is a predeterminant to understand better dissolution, better bioavailability, better permeation. So solubility has to drug should have some solubility, then only it can able to reach the systemic circulation. So to enhance the solubility, this technique we call solubilization. So various approaches or technique can be adopted to improve the solubilization, such as change in the pH, co-solvency, dielectric constant method we can adopt, or solubilization by complexation or hydrotrophic or chemical modification of a drug substance. So, as I said, the GI system, gastrointestinal tract, we have different pH environment. So, pH going to play a very important role in pre-formulation development of a dosage form. So, injectables, it is understood that formulations should be in the range of pH 3 to 9 to prevent tissue damage and pain at the injection site. Similarly, the oral syrup cannot be formulated too acidic for palatability reason. Similarly, more alkali formulations may attack the glass container. Similarly, the drug is more susceptible degradation in acidic pH than it is can be formulated into a delayed release formulation or a extended release formulation or a control release formulation to be is a ideal condition dosage form to avoid the degradation in acidic pH. The pH of the formulation must not sensitive to the site of the application. For example, pH of the buccal application should be the range of 6.6 to 6.8. GIT, gastrointestinal tract, so a variety is of pH range starting from pH 1.2 for the stomach to 6.6 buccal and pH 7 to 8 in small intestine throughout its length from the oral cavity to the colon. So there is a varieties of the range of the pH will be in GI system. So according to that, we have to develop our delivery system or dosage form, and that part of the study has to be carried out at pre-formulation study. At this stage, we have to determine which pH, what pH the drug will be remain stable and can able to produce a better delivery system or better dosage form. As a key point to note, the drug formulation should be stable at the pH intended for the target site of absorption. Coming to the dissolution, dissolution rate is defined as the quantity of the drug substance dissolved per unit time with a specific circumstance of temperature and solvent conditions for a liquid or a solid interface. This process is called dissolution, and the rate of dissolution is the transfer rate amount of the drug substance from the surface of this solid to the solvent system is called rate of dissolution. And the rate of dissolution basically determined by Noyes-Whitney equation. The dissolution rate is considered to be a rate limiting step at the site of absorption for drug solution. The rate limiting step is the predeterminal and determine how the rate is going to be, how the next delivery system going to cross the dissolution step, then going to adsorption step, then going to be the viability to systemic circulation is the critical factor. Dissolution rate is going to considered to be the predeterminal for the step for the drug availability into systemic circulation for a drug solution preparation. So drug dissolution is followed by reaching into systemic circulation and is depend on the type of dosage form like solid oral dosage form like tablet, capsule or suspension, or intramuscular preparation like pellets or suspension going to determine how the drug is going to dissolve. So it is, as I said, is a rate limiting factor. Means it is the determinant factors which going to decide the fate of the molecule, fate of the drug substance, how it's going to reach to the systemic circulation, depend on how the dissolution rate is proceeding for further step. In this graphical depicts that here the dissolution profile of the same drug has to be carried out at in zero point 0.1 N hydrochloric acid and pH 2 and phosphate buffer pH 6.8, and it is noticed that the drug in the rate of the dissolution in different environment, the rate of dissolution with respect to time, you can find there is a changes. So the drug in acidic environment, how the releases, and drug in basic environment, how does it influence, that is has to be carried out in pre-formulation study to understand where the drug is having a stable delivery system. As I said, the stability also very important to understand in a different pH condition, how it's going to be, how the temperature going to influence. So to know about the stability of the dosage form, normally the stability analysis has to be carried out as per the ICH guidelines called International Conference on Harmonization on Stability Study under Q1A R2 regulatory guidelines. Under the different stress conditions such as long-term stability testing or accelerated stability testing for the minimum three different time points, or the testing should be include the effect of the pH, temperature, humidity, and photolysis, and under stress condition how the drug is going to be behave. So that's considered to be a stability analysis. Stability studies during the pre-formulation stage are most important factor to understand how the chemical substance gets stable and where it will be and how the instability takes place. So many pathways will be there for the instability of the drug substance or the formulation. So we have to determine which condition, which delivery system dosage form will be become more stable, and what is the instability pathway for that this new chemical entity or a formula or a dosage form. So the degradation pathway, either in a solid state pathway or a liquid state pathway in a formulation, has to be determined. So chemical stability or physical stability has to be carried out in a pre-formulation study stage to understand that which the dosage form and the new chemical entity, where it and how the instability progress with respect to time and the environmental conditions. So the physical observation could be to understand, to check or see that how it formed the change in any color, discoloration or odor or formation of liquefaction or formation of the cake had to determine physically in the stability study during the sampling state. And as I said, minimum three time point we have to collect the sample and we have to analyze physically how these things happen and change with respect to time. Coming to this physical observation, degradation can also be identified. The changes, the physical changes can be identified by the help of mass spectroscopy method or HPLC or a DSE or NMR or a FTIR study. Stability in a toxicology formulation to understand, to evaluate the samples of toxicology preparation for stability and potential homogeneity problems can be determined, and to understand how the stability of the formulation going to be. And to understand that, normally we know that water or vitamins or minerals or enzymes are present in the feed, which can severely reduce the shelf life of the product or drug substance. Solution or suspension of a toxicology preparation should be checked for easy manufacturing and then store in a flame sealed ampoule at various temperature. In addition to chemical stability, the suspensions should be subjected to an occasional checking to check the dispersibility. So stability analysis as per ICH guidelines coming under that, how the solution stability has to be carried out. The objective of this study is that identification of the condition necessary to form a stable solution dosage form. And as we know that in a solution dosage form of development of a new drug compound in formulation development, we know that pH, ionic strength, co-solvent and light, temperature, oxygen going to influence the stability. So in a pH stability study protocol, the experiment to confirm to that, we have to perform a pH stability study profile to understand that at which extreme pH condition and temperature the product going to unstable. So those studies can be carried out, and three stability studies are carried out following in a different condition like point 1 hydrochloric acid at 90 degrees centigrade or solution in water at 90 degrees centigrade or point 0.1 sodium hydroxide solution at 90 degrees centigrade. So different condition situation that how that solution is going to be going to stabilize or going to the stability profile going to be or in different pH condition how the pH profile and where is the which pathway the drug is going to be degradation process is to be determined. As I said, the solutions stability is the these experiments are intentionally done to confirm the SS specificity for maximum rates of degradation. Aqueous buffers are used to produce a solution with wide range of pH values but with a constant levels of drug concentration, co-solvent and ionic strength can be used to understand this process, and the solution stability can be carried out. And in this process, the rate constant, how the rate process going on, with to temperature, and pH will be determined. So pH versus log K value, and the K is the rate constant going to be determined for each formulations. And example here you can see here ampicillin degradation pathway, how is going to be in a solution form, how hydrolysis of aspirin has to carried out with different pH condition. Similarly, hydrolysis of hydrochlorothiazide has to perform in different pH condition. Coming to the solid state stability, the objective saying to identify the stable dose storage condition for a drug in a solid state, and identification of the compatibility of excipient with the drug or new chemical entity in development of a stable dosage form or stable formulation. And the characteristics for the solid state stability study, to understand the reaction, as we know that solid state stability will be process very slow degradation pathway. So the rate of appearance of the decay product is measured rather than the amount of the drug remain unchanged, because the drug compound or the drug substance in a solid state very slowly go for the degradation pathway. So the degraded metabolic products going to determine rather than the drug compound in stability study of a solid experimentation of preformulation study. To determine the mechanism of degradation, thin layer chromatography, fluorescence or UV visible spectroscopy method can be adopted to understand how the solid state stability is going on. To study the polymorphic changes, as we know that DSE or differential scanning colorimetry or IR spectroscopy can be analyzed, can be used to the understand the solid state stability pathway. In case of surface discoloration due to oxidation or reaction with the excipient, surface reflectance equipment may be used. Mostly, the solid state stability study protocol where the samples are placed on open screw capped vials, are exposed to a varieties of temperature, humidity, and light intensity. After the desired time, the samples are taken out and measured by HPLC method. As I said earlier, the HPLC may need 5 to 10 milligram samples each time point. Similar DSC 10 to 50, IR 2 to 20 milligram. To test the surface oxidation, samples are stored in a 25 ml vials for injection and kept with Teflon lined rubber stopper. The stoppers are penetrated with the needles and headspace is flooded with a desired gas. The resulting needle hole is sealed with a wax to prevent the degassing. After fixed time, those samples are removed and analyzed. This is the simple protocol how the stability study protocol and the conditions will be for as per ICS guidelines. Like you can look in taking into the account for the heat, that in case of the solid, it could be the heat temperature could be 4, 20, 30, 40, 40 with 70 relative humidity or relative humidity 50 or 75. Moisture uptake carried out in 30, 45, 60, 75, 90% relative humidity at relative temperature. Similarly, physical stress normally carried out by using a ball mill, and the physical stress will be determined by employing a ball mill method. Similarly, aqueous solution, the pH 1 to 9 and 11 at relative temperature and 37 degrees centigrade at the body temperature. So here we are going to understand how the pH from 1 to 9 with a different temperature condition going to influence the instability pathway or the stability pathway of the drug substance. And reflex in 1 molar hydrochloric acid, 1 molar sodium hydroxide. Similarly, light, it could be UV 254 or 366. Oxidation, the spalling of oxygen with relative temperature and UV maybe accelerate the breakdown. RT is the ambient room temperature can be vary from 50 to 250 degrees centigrade. Saturated solution means magnesium bromide or sodium bromide, sodium chloride, all can be used respectively at pH of maximum stability in sample aqueous solution can be determined. Coming to the drug excipient compatibility or drug excipient compatibility screening process, it is a hypothetically the dosage forms are prepared with a various excipients and exposed to a various condition to the study the interactions of the drug and excipient. As we notice that simply in making of a tablet dosage form, more than 5 ingredients considered to be excipient can be used in formulation development of a tablet dosage form. So in the next lectures, we are going to discuss how to make a tablet and tablet delivery system. We are going to discuss in the next lectures, next future lectures. So, as I said, the drug excipient is going to be a very critical role because the drug may get deteriorated, may alter its performance or the assay contents by the presence of the excipient. So, knowledge of the drug excipient interaction is therefore is very useful to determine to determine the formulator to select a proper drug and excipient. Typically, tablet contain a binder disintegrators, lubricant, filler, etc. We know that there is a lot of the ingredients we're going to use in the making of the tablet. But how does those drug and excipient compare? Interacting with them, they lose their therapeutic characteristics has to determine during the physiochemical properties. Compatibility screening for a new drug must be considered two or more excipient for from each classes. When we are doing a stability analysis and drug excipient compatibility study, so most of the time each category, suppose a binder, we are have to take two binders solution binder product, then mix with the drug. Similarly, suppose you are using a disintegrators or fast disintegrator, then you know cross providone, cross carbamylose, sodium starch glycolate. These are the excipients can be used combined with the drug and how the stability is going to be and drug excipient compatibility going to understand in detail so that better suitability which excipient go for with the new chemical entity going to determine at this stage. So drug excipient compatibility screening is very significantly influence the stability and bioavailability of the drug substance. That's why drug excipient compatibility data submission is essential for new formulation as per FDA. Regulatory agencies provide long-term stability and analytical techniques can be adapted, and here we can see that determine the chemical physical interactions. So DAC study is a very important role as per the regulatory point of view. US FDA guidelines require the drug excipient stability study protocol and data has to be present for a new chemical entity or a new formulation. Provide a idea for a long-term drug stability, then mitigate the difficulties in formulation stage so that we are going to get a stable final solid dosage form or dosage form. Determine any chemical or physical interactions with the drug and excipient and how they can affect the stability and bioavailability of the formulation going to be determined in this drug excipient compatibility study or screening method. So various screening techniques are used to understand the drug excipient compatibility. Earlier, we discussed in detail like differential scanning calorimetry, thermogravimetry, or FTR spectroscopy, XRD, diffuse reflectance spectroscopy, HPLC method. Radio labeling can be also used to understand the drug excipient compatibility. This slide depicts that in case of a drug excipient compatibility study can be carried out by using XRD X-ray diffractography refractometric methods, where this example indicates that how the pure drug of glycologide and after making a formulation with the drug excipient compatibility, the characteristics nature of the drug will be retained same, whereas the other characteristics of the excipients or certain parameters will be blended together or merged together with the drug. So by this analysis, comparative analysis of the pure drug with the formulation or developed formulation, we can understand how the drug is going to be stable in which condition and which parameter going to influence the stability of, and which parameter, which excipient going to influence the degradations or losing of the drug components of the formulations. Similarly, DAC, as I said, the sharp peak of the drug components, drug pure compound, compare with the formulation physical mixture with the drug with the excipients and the formulation, all has to be analyzed together and to see that whether the characteristics peak of the drug will be retained or not. If not retained, how much it reduce and what is going to be happen if you are making a formulation. Suppose you are making a nano formulations where the drug characteristics totally going to change, so this parameter has to be analyzed thoroughly in drug excipient compatibility screening. And in this case, we are using differential scanning calorimetric method to understand the drug excipient compatibility. Similarly, FTIR is another technique, analytical technique method to understand the drug excipient compatibility. Here, what we do, individual excipients and mix with the drug and drug individually, drug excipient, all profile will be carried out and now run the FTIR study for drug, individual excipient in physical mixture and the optimized formulation. Now comparatively analyze that whether the characteristics of the behavior of the drug is retained or not. So very important part we have discussed together all the way within 4 lectures, and our main intention of this study is that how to develop a formulation which is going to be a stable and take further to a clinical study to do a develop a delivery system or dosage form for the patient. So pre-formulation is going to consider to be a foundation for a basic develop a safe and effective delivery or dosage form. So, formulation point of view, the selection of a suitable excipient based on the drug's profile. So, we have to understand that which excipient is compatible with the drug should be selected, because many times notice that the excipient may alter the drug characteristics. Determining the appropriate dosage form like a tablet, capsule, or injection, also going to understand how the stable dosage form. Suppose drug is having a hydrolytic pathway for the degradation, so normally we go for a solid dosage form. Developing a method for scale up and manufacturing also going to be important one, because when you develop any formulation product or formulation in a pre-formulation state, but it is unable to take further into scale up and manufacturing in the large scale, then that type of the formulation study and development of the dosage form is not ideal in the later stage of the product development. So that's the region pre-formulation study has to taken care of in making of a delivery system or development of a stable, safe, effective dosage form. A regulatory point of view, when we are analyzing pre-formulation study, either it's in case of IND or NDA application, like investigational new drug application or new drug application, pre-formulation study is considered to be a very important and crucial pre step for development of dosage form or a delivery system. So documentation of those is essential, because it's not only to regulatory satisfaction but also to develop a stable, effective delivery of formulation or dosage form. Comprehensive reporting of the findings to this guide formulation development and regulatory requirements. So the systematic or approach in developing the pre-formulation study is highly essential to understand the formulation development and regulatory submission requirements. So, in a simple concluded part, to say that pre-formulation is a proactive phase study where deals with the transformation of new chemical entity into a clinically safe, effective, and most importantly, stable pharmaceutical formulation. So that's the reason pre-formulation has to be emphasized more uh, a strict way to develop a stable formulation. This has to be carried out under a suitable protocol and uh, mm, methodology has to adapt, document to develop a stable formulation. As we have discussed earlier, that in these four lectures, we understood that this pre-formulation study is a multidisciplinary studies where you can integrate the chemistry, biology, or engineering principle in optimizing a drug development. Hope you have understood the basic understanding of pre-formulation study, how it's going to play a very important role in the product development and delivery and of the dosage form. Thank you very much for your support and understanding this lecture of pre-formulation. We have, if you have any questions, you can comments or you can ask to me through in the YouTube discussion section, or you can directly contact me through my email ID bibuprasad25 yahoo.co.in. Thank you once again. I have received many queries and suggestions and encouragement throughout this lecture, and I received many encouragement for this future lectures related to pharmaceutical sciences topics. Definitely, this is encourage us to do that, and we are definitely committed to deliver much better and much advanced delivery techniques or methodologies or topics related to pharmaceutical science in future days to come. Thank you once again for your support and encouragement. Once again, I request please like and share and our contents, and if you subscribe, then that will be encourage us to make future lectures on pharmaceutical sciences. So once again, thank you all for your support and encouragement, and hopefully we will come out with a new advanced topics for your futures days to come. Thank you once again. Thank you.